All right, today we're going to be talking about our similar triangles, and we're talking about theorems, postulates to prove that triangles are similar. So as a quick review, remember similar means congruent angles and proportional sides. So now we're going to prove if the triangles are similar. So one of the ways that you can prove triangles are similar is by using the angle-angle postulate, or sometimes you'll see it as angle-angle-angle. But what it means is two angles of the triangle are congruent to two angles of another triangle. So if two of the angles are congruent, then you know that they are potentially similar, which makes sense because then your third side would have to be the same also. So if we know those two, then we know that these are going to be similar. So at least two. The next way is by side, side, side. Now this is the same property as proving triangles congruent. However, the biggest difference with this side, side, side is the corresponding sides of two triangles are proportional. And if they're proportional, then it's similar. So just that, you set up a proportion. So if I were to do 28 over 14, does that equal 36 over 18? And does that equal 32 over 16? If they all equal each other, then it's proportional. All right, the next way is side angle side. Again, this is one of the other ones to prove a triangle congruent, but instead of all the sides needing to be equal with congruent, in this case, two sides just need to be proportional as long as the angle is congruent. So if you notice, 4 and 8 are proportional, and then 3 and 6. So they all are the same proportion because we know 4 over 8 equals 3 over 6. So that's true. And they both have an 80-degree angle. So we know since it matches sides and one angle, so two sides and one angle in between, you know that these are similar. All right, so let's go and get started with some of the problems. So we need to determine if it's similar. If so, we have to write a similarity statement. So with similarity statement, remember order matters. Oops. I'll do it. There we go. All right. So order matters when you're doing your similarity statement. All right, so let's look at this first one. We need to think about the sides that are congruent. So it matched this side and this side. And then, so that's for this triangle. And then for this triangle, we have this side is congruent to this side. So if you're to look, you have a side, an angle, and a side. And this would be side, angle, side. So now, just match it up. If we were to do triangle TSR, since we said T goes with this side, we know that X is going to go with this side. And if I know S is in the middle, well, S should be in the middle here. And then lastly, if R is here, W is here, and you know that they are similar. So these can be proven similar due to side, angle, side. You could also do your triangle the other way. This way is okay also. All right. So this one, I'm going to go through this first and then come back to this one. All right. So we need to determine if it's similar. So in this case, you actually have two triangles. I drew a smaller triangle. And then I drew a larger triangle outside. So I separated this into two different triangles. So let's look at the smaller. We want to know, is it proportional? So if I were to go 8 over 12, I could do that, and I get 2/3. And then if I were to do 10 to 15, I also get 2/3. So far, my sides are proportional, but we don't have any other information. So not enough info. So in this case, they are not similar because we have not enough info. All right, because we only have 2 sides, and side is not one of the options. All right, so now let's look here. Let's go to number 2. So set up your proportions and make sure you've got your corresponding sides. Now, if you notice, I've got 12 here and 12 here. So that means I've got 9 here and 9 here. So however you choose to do it, but then I definitely know 8 and 6 have to go together since they are different. So if you were to go 12 over 9, I want to know, is that the same as 8 over 6? So if it is, it's similar. And then if it's not, we've got 2 of the sides, 3 sides, so you need to determine, is that going to be one of that? So side is what I would be looking at to determine if these are similar or not. So finish this one to determine if it's similar. And then now let's look here. So now I've got 2 angles. So we need to know, I'm thinking AA. So let's see if it's this one. And right now, if this is 90, 60, this has to be 30, and this has to be. So do they all have the same? Yes, they are similar. And that's because of AA. All right, so now let's go here, and now we're going to identify triangles or similar triangles and find the variable in sides. So let's first set up a similarity statement from here. And when you're doing this, I like to color code. So it's talking about the indicated side. So we're going to find this at the end. So first let's find out, are they similar? So I know this angle goes with this angle. I know this angle goes with this angle. So that means these two have to go together, and then you have your corresponding sides. So let's go ahead and let's set up our sides. So I want to know, is this side over this side? And it doesn't matter which way you do it. And then I put, since I started with this one, 12 goes with that one. So if you notice, these are lined up. And then this one goes with 15. And if you notice, those are lined up. There's different ways to set this up. All right, so you're going to cross multiply. And remember, it's all of this times 12. And then all of this times 15. So when you get it, you'll get here and you'll get here. All right, solve for x, and you have x equals 15. So now that I know x is 15, substitute it into here, but we're looking for side AC. So we're going to put 15 plus 1, which is what we're looking for, which is 16. All right, let's look at this one. And we're going to make a similarity statement based on the information it gives us, and we're going to look for JL. So if you notice here, this is a parallel line, and this is a transversal. So if you think of it that way, with the transversal, this is congruent to that because they're opposite sides of the transversal. And then also, this is congruent to that because this is a different transversal right there. And then we know this is congruent to that because they are vertical angles. So let's go ahead and set it up and make sure you do your proportional sides. So we said JL is going to go with ML, which is here. So I set up my proportion here, and then now I'm going to do my other values, which is JK, which has to go with MN. And I set up my proportion here. So again, do your cross multiplying and then solve for x, which is 10. But remember, we're looking for JL, so now that you know that x is 10, you can go there, but we're looking for this length right here. So plug it in and you get 28. And that's your final answer. All right, I want you to go through and you're going to try some of these. So remember, set up a proportion, make a similarity statement, and then solve for your variable. So here you're solving for two things, here you're solving for two things. And remember, similar means congruent angles and proportional sides.